Somewhere in the Atlantic in 1943, a German submarine slipped beneath the surface carrying cargo Berlin could not afford to lose. It never surfaced again. Berlin waited. Tokyo waited. The technology each needed from the other sat 2 miles underwater. The Axis alliance was not a partnership. It was a postal service that kept losing the mail. On September 27, 1940, Germany, Italy, and Japan signed the Tripartite Pact in Berlin, a single document binding 3 nations into one declared alliance. In propaganda terms, the alliance looked monolithic. In operational terms, Berlin and Tokyo sat roughly 14,000 miles apart, separated by ocean, not a shared border. No shared land border existed between them, no air corridor, no reliable radio link secure enough to carry classified technical data across that distance. Allied naval forces and aircraft controlled or actively patrolled the Atlantic, the Indian Ocean, and the waters between. The geography of the alliance was already working against it. The alliance that unsettled Washington existed in logistical terms almost entirely on paper. The distance alone made cooperation a structural problem before any enemy action intervened. Surface shipping between Germany and Japan was suicidal by 1942. Allied aircraft and convoy escorts sank anything that moved above the waterline. Only submarines could thread the British blockade round the Cape of Good Hope and cross the Indian Ocean to reach Singapore or Kobe. Of all the submarines that attempted this full trans-oceanic crossing, only around 6 completed the voyage successfully across the entire war. A combined tally of both German and Japanese boats that managed to survive the journey end to end. Cargo moved in both directions, but barely. Between 20 and 40% of goods ever reached their destination. The rest went down with the hull. The pipeline carrying the most consequential military technology of the war operated at an 80% failure rate. That was the only thread connecting the Axis powers. In August 1942, the Japanese submarine I-30 docked at Lorient, France, carrying something Germany's engineers had not managed to build themselves. Its cargo hold contained engineering drawings and physical examples of the Type 91 aerial torpedo, the weapon that had torn open the hulls of American battleships at Pearl Harbor on December 7, 1941. Germany's own aerial torpedo program lagged behind. Here was a weapon already proven in one of the most operationally precise naval strikes ever executed, delivered by hand across roughly 11,000 miles of ocean. Germany took the drawings and reverse-engineered the design. Japan delivered and expected equivalent generosity in return. The exchange rate between the two allies, as both sides would discover across the years that followed, was never equal. By 1943, Germany held 3 technological edges that Japan's military desperately needed: centimetric radar, precision optics, and jet propulsion. The Me-262, the world's first operational jet fighter, had made its first jet-powered flight on July 18, 1942, and was moving toward series production. Japan's Navy and Army Air Forces were watching the Pacific Air War tighten around them. American P-38 Lightnings and F-6F Hellcats were outclimbing and outrunning everything Tokyo produced. German jet propulsion represented a generational leap, not an incremental improvement. Tokyo requested the specifications. Berlin, in principle, agreed. Getting the specifications from one continent to another was an entirely different question, one that the ocean would answer on its own terms. Germany launched Operation Barbarossa on June 22, 1941. Hitler expected Japan to strike the Soviet Far East simultaneously, squeezing the Red Army between 2 fronts. Japan refused. Tokyo had signed its own neutrality pact with the Soviet Union in April 1941 and was looking south, not north. This was Japan's Nanshin strategy, a southward push toward the resource-rich territories of Southeast Asia. Siberia held no oil, no rubber, no path to the empire Japan was building. Stalin had massed forces on his eastern flank, precisely because he feared a Japanese strike from Manchuria. Those divisions waited through the autumn of 1941, and Japan never came. When Moscow held in December 1941, those eastern divisions had moved west in time to stop the German advance. Hitler had built his eastern strategy around a Japanese move that was never going to happen. 3 days after Pearl Harbor, on December 11, 1941, Adolf Hitler stood before 855 Reichstag deputies in the Kroll Opera House and declared war on the United States. The Tripartite Pact did not require it. The treaty bound its members to mutual defense, and Japan had struck first, not been struck. Hitler chose this war himself. Roosevelt had spent months maneuvering the United States toward full Atlantic engagement. Hitler handed him a declaration, clean, legal, and complete, within 96 hours of the Pearl Harbor strike. Hitler had not anticipated Japan's attack on Pearl Harbor. The alliance, meant to project unified Axis power across two hemispheres, had delivered something neither signatory had planned for. A submarine running the route from Kiel to Penang was not a warship on a combat mission. It was a pressurized steel tube covering roughly 14,000 miles in 60 to 90 days. Crew bunks were removed or compressed to make room for cargo blocks. The men who remained lived inside a machine that had been stripped down around them. The Bay of Biscay alone was the most hunted stretch of water on Earth in 1943. Allied aircraft and surface escorts patrolled it in overlapping grids. Beyond Biscay stretched 6,000 miles of open Indian Ocean. Then Japanese-held harbor approaches. One ASDIC contact, one engine failure, one navigational error, and the cargo never arrived. Across the entire war, 96 people crossed by submarine from Europe to Japan. 89 made the journey in the opposite direction. The entire operation, 4 years, 2 oceans, moved fewer people than a single corporate department. In August 1943, U-511 reached Japanese-held waters, one of only 6 submarines to complete a full trans-oceanic voyage during the entire war. It crossed the Atlantic, rounded the Cape of Good Hope, threaded the Indian Ocean, and arrived. 90-plus days of exposure. One payload, one chance. Its arrival was a logistical achievement by any measure, but U-511 also defined the hard ceiling of what was possible: a single vessel, a single manifest, months between dispatch and delivery. Germany was manufacturing jet engines inside purpose-built factories. Japan needed the metallurgical formulas, the tooling tolerances, the complete engineering specifications, not a fragment of them. Blueprints for jet engines, living tissue samples, enriched uranium, the things each nation most desperately needed from the other, were, by definition, the hardest to force through 14,000 miles of open ocean. The cargo moving through this underwater corridor reads like a catalog of military urgency. From Germany, radar components, optical glass formulas, blueprints for German fighter aircraft. Messerschmitt airframe specifications, synthetic rubber patents from IG Farben. Japan sent back raw rubber, tungsten, tin, quinine, and the torpedo drawings. The exchange was lopsided in kind. Germany shipped industrial intellectual property. Japan shipped strategic raw materials. Both nations needed what the other had. Both were structurally incapable of reliably delivering it. Every item on these manifests was a gamble. Against Allied interception, against mechanical failure, against 14,000 miles of open ocean. By 1943, Japan's military engineers had reached a conclusion they could no longer argue away. The piston engine had a ceiling, and American fighters were above it. The A-6M-0, which had torn through Allied air defenses in December 1941, was being systematically destroyed by faster, better-armed American aircraft 2 years later. Tokyo formally requested complete engineering specifications for 2 German engines, the BMW 003 axial flow turbojet and the Junkers Jumo 004. Berlin agreed to share them. Some drawings loaded onto vessels that never reached port. Others arrived in fragments, radio transmissions so degraded that Japanese engineers could not reconstruct a coherent design. Japan built its own jet program from what little had survived the crossing. The Nakajima Kika drew heavily from German BMW 003 documentation, reconstructed largely from a single engineer's personal notes and a handful of photographs smuggled aboard a submarine. The Kika prototype completed its maiden flight on August 7, 1945. Lieutenant Commander Susumu Takaoka at the controls, 20 minutes airborne, the engines holding. Hiroshima had burned the day before. The failure rate of the submarine corridor was not simply bad weather or mechanical breakdown. Allied intelligence had already mapped the water. Ultra, the intelligence operation running out of Bletchley Park, cracked German Enigma traffic and decrypted U-boat position signals in under half a day. Allied warships rerouted convoys with uncanny precision. Every Axis submarine threading the Bay of Biscay moved through water the enemy had already read. May 1943, Black May, German submariners called it. Allied forces sank 41 U-boats that month alone. Between 60 and 80% of cargo on trans-oceanic Axis submarine runs never arrived. The research puts it differently. Only 20 to 40% of goods ever reached their destination. The math is the same. Allied intelligence had cracked German Enigma signals and was reading U-boat position traffic in near real time. Bletchley Park fed intercepts to convoy commanders. Those commanders rerouted warships. The submarines threading the Bay of Biscay were moving through water the enemy had already read. This was not attrition through bad luck. It was interception running at scale, systematic, informed, and grinding the Axis supply line down to a fraction of what either Berlin or Tokyo had planned for. 96 people made the submarine crossing from Europe to Japan across the entire duration of the war. Another 89 traveled the other direction. Engineers, weapons specialists, military attachés who carried technical specifications not on paper but memorized, committed to memory because no document could be trusted to survive. Some of those 96 and 89 people were not merely carrying technology, they were the technology. The knowledge inside them could not be photocopied, radioed in fragments, or recovered from the ocean floor. An engineer who had memorized tooling tolerances for a jet engine intake was worth more than a blueprint that might sink. A weapons specialist who had watched the assembly sequence, who carried the process in his hands, that person was irreplaceable in a way no document could be. When a submarine went down, it did not simply lose metal and rubber. It lost the engineer who understood exactly how to recalibrate a BMW turbine's fuel injectors under altitude conditions. That knowledge died with him. No archive held it. No second copy existed. The war continued, and the gap it left simply never closed. By 1943, American surface ships and aircraft were finding Japanese vessels at night and in fog, conditions that had previously made them invisible. Germany had centimetric radar systems that could close that gap. The specifications were prepared and loaded onto submarines bound for Japan. What reached Japan came in fragments. Partial drawings, incomplete tolerances, pieces arriving months apart through whichever submarines survived the crossing. Japanese engineers built only 3 Würzburg-type radar sets from German specifications. One reached operational status before the war ended. 1. Technology transferred at roughly 40% efficiency across 14,000 miles in 90-day increments cannot win a war that moves faster than the mail. By early 1944, the strategic map had shifted in ways neither Berlin nor Tokyo could obscure from themselves. Germany had lost North Africa. Italy surrendered in September 1943. At Kursk, the Red Army broke through in July 1943, and 47 German divisions fell back across an estimated 600-mile front. Japan surrendered Guadalcanal in February 1943 and ceded island after island across the Pacific. Neither could absorb the other's pressure by opening a second front. The Axis alliance, at the exact moment both partners needed it most, existed only as a letterhead. The submarines still sailed. But what they carried no longer had the power to matter. Run the numbers forward. The Nakajima Kika flew its first test flight on August 7, 1945. Japan's engineers had spent years reconstructing German jet specifications from fragments, partial drawings, degraded radio transmissions, a single engineer's notes. The Kika was essentially a proof of concept when the war ended, not a deployable weapon system. Full German jet specifications arriving intact and early enough to allow factory tooling, test flights, and series production needed years of lead time, not months. The submarine corridor that delivered them in pieces across 14,000 miles in 90-day increments made that timeline structurally impossible. The math was never close. Japan's industrial base then had to do what the Nakajima engineers actually did with the Kika, reconstruct a partial design from surviving fragments, build and test prototypes, and retool factories that had never produced jet components. The Kika prototype flew on August 7, 1945. The BMW 003 documentation it drew from had been in transit, fragmentary, and reconstructed over years. The gap between receiving incomplete specifications and producing a flying aircraft consumed the better part of the war itself. That puts operational Japanese jet fighters in the air no earlier than 1945. American B-29 raids on the Japanese home islands began in June 1944. The atomic bomb fell on Hiroshima on August 6, 1945. Days later, Nagasaki. The Nakajima Kika flew its single test flight on August 7th. The window in which jet technology could have shifted the Pacific Air War was not narrow. The technology did not simply fail to arrive, it arrived into a war that had already closed around it. Some of those blueprints did reach Japan. The BMW 003 documentation that Nakajima engineers used to build the Kika arrived in fragments across multiple crossings, reconstructed from partial drawings and one engineer's personal notes. That is not a success story. That is the ceiling of what the corridor could actually deliver. Complete specifications arriving intact in time for factory retooling, test flights, and series production. That timeline required years. What Japan received required years of reconstruction just to produce a single prototype. The submarine that sank took its cargo with it. The one that arrived delivered pieces. Both outcomes fed the same result, a jet program that flew its first test flight on August 7, 1945, the day after Hiroshima. A steel tube, 14,000 miles of ocean, and a failure rate between 60 and 80% across 4 years of war. The alliance that unsettled Washington in 1940 did not die in a single hull. It died in the gap between what was sent and what could be used, one manifest at a time, 2 miles down or months too late. The documented losses are specific. I-34 was sunk in November 1943 en route to Europe, carrying cargo and personnel that never reached their destination. U-1224 went down on May 13, 1944, in the Atlantic. I-52 followed on June 23, 1944, intercepted by American aircraft operating from the escort carrier Bogue, carrying 2 tons of gold, raw materials, and technical specialists. No survivors. No cargo recovery. 3 vessels. 3 manifests. 3 crews. The ocean kept everything. Some manifests are classified, others went down with the hull. What sits on the floor of the Atlantic is not metaphor. It is cargo, it is metal, it is people. The submarine corridor that connected Berlin to Tokyo ran at a documented 60 to 80% loss rate. Most of what was loaded onto those vessels never reached the other side. The cargo that sank included technical drawings, optical glass formulas, radar components, and, according to German naval records, specialists traveling without official passenger documentation. Their names were not on lists that survived the war intact. The knowledge they carried, tooling tolerances, assembly sequences, processes, held in memory because no document could survive the crossing, went down with them. No salvage operation retrieves what a person knew. The metal can rust on the ocean floor for centuries. The expertise it carried is simply gone. That was the structural reality the submarine corridor produced, not a pipeline, but a series of single points of failure, each one irreplaceable, each one permanent when it ended. It is aluminum and steel and paper. It is the specific technical knowledge carried inside specific human beings who did not reach the surface. The war ended without it. The engineers who might have used those specifications died in different years, in different places, under entirely different circumstances. The documents decomposed. The technology gap they were meant to close never closed. Some of what was lost is still down there. The documented Axis courier submarines destroyed in the Atlantic between 1943 and 1944 carried cargo that was never retrieved. No salvage operation reached those hulls. No recovery effort pulled the manifests back to the surface. The wrecks sit at depths that make recovery impractical with any technology that existed then or for decades after. The specific contents of several manifests remain incomplete in the historical record. Not because the documents were classified, but because the vessels went down before anyone could record what they held. The ocean kept it. The documented crossings tell part of the story. Individual missions carried specific counts. I-8 moved personnel. I-52 carried crew and passengers, specialized engineers, and attachés crossing in ones and twos aboard submarines not designed for passengers. The cumulative total across 4 years was small. Dozens, not hundreds. Allied logistics in the same period moved millions of men and millions of tons across 2 oceans on surface ships, in convoys, through ports operating around the clock. The Axis submarine corridor moved fragments of knowledge through a straw. Allied supply chains moved armies through a pipeline. The Axis technology transfer was not defeated by Allied interception alone. It was defeated by the arithmetic of distance, industrial scale, and an alliance that shared enemies but never shared a strategy.